I'm going to resume recording. And yeah, it's already 12. By my own principle, the way I do things, even if I'm the only one here, I'm going to start presenting anyways. So I hope the rest of us were here. All right. So I believe is my screen still being shared? No, not that shared. Let me share the desktop. All right. Thank you for coming. Welcome to Edusify. We appreciate you attending this webinar with us. The webinar is going to be, whether you have a chance to attend or not, the webinar is going to be recorded, and we are going to be able to have access to the webinar material that we are presenting today. We are excited that this is the first time we are presenting a webinar on sciences, our STEM program, sciences, technology, engineering, and mathematics. So this is the first time we are doing this, and I'm very excited to introduce some very experienced teachers that are going to be discussing the number of topics that are very important when it comes to sciences. So one of the topics that we are going to be discussing today is about energy. As you know, there's no way we can talk about sciences without talking about energy. Energy is very important, right? And the second one is we're going to talk about matter, all right? And another topic that's also dear to us, to science, or to sciences in particular, is the Earth system, the system of the planet Earth, where we live in. So we're going to be talking about that. Now, before we do that, let me quickly talk about Edusify. So what is Edusify, who we are, and what do we offer? So we are a platform that actually caters to your needs online and in person. And our primary market is in Canada and the US, North American market. That's our primary market. So we focus on kindergarten to grade 12 in both countries, and we have a number of offerings on different subjects. We offer subject training in computer programming, otherwise known as coding, where we help students to build essential tech skills. As you know, the trend now is artificial intelligence. So that is what is in vogue. So, and it's born out of the skill, the tech skill. So we can help your children to develop, tech skill, what they need in the area of Python, JavaScript, web development, app development, engineering, and all that. And the second one is music. So we offer training in, various musical instruments, from piano to trumpet to saxophone to violin to drums, guitar, ukulele, and you can continue to mention them. So we offer training on that. And the training is not only limited to online. We also offer training in person, for that as well. And also mathematics. Now for mathematics, we use the syllabus, we use the curriculum of Canada and the US, and we offer our training on to help children to be able to reach their mathematical potential. So from grade 1 to 12. So we help them. So I want you to explore that with us today. You can make inquiries from management, and we'll be able to direct you in the right way. Followed by languages. Now we offer training in different languages. As a matter of fact, we offer languages in local languages, country-specific languages like Swahili, like Japanese, like Korean, and like Yoruba language. Also, we offer languages like French, English, Spanish, which are supposedly international languages as well. We have, we offer a range of programs and packages that can help you to be able to reach your potential in those languages. Now, last but not the least, we are talking about STEM, which encompasses sciences and technology. So, which is the subject of today's webinar. So, let me just, so I hope, if you have any question, let me know at the end of the webinar. This is me. My background is actually in sciences. I have my bachelor's in geology and master's in geophysics. Currently working on my PhD program in management. So I've always wanted to work in education to be able to help students to reach their potential in education, to make sure that the educational facilities and materials are actually readily available and accessible to students globally. So this is one of our instructors for today, our presenters, and she's one of our teachers. Her name is Oluwafemi, science teacher. So she uses inclusive and active learning techniques to help learners. And you're going to see the way she's going to present today, and that's going to be a testament to the approach that she takes. Either she's taking you one-on-one or you are in a group. So she makes sure that you are engaged and make sure that the session is informative and also help you with assessment, right? We also have Abayomi Tafa, who has been a teacher and is currently also a classroom teacher. So he's helping to engage students to engage with their learning, with their teaching. He can teach science at all levels, from elementary level to middle school or even to high school. He has a lot of experience in that. And last but not the least, which is actually supposed to be the first speaker, is Damilola. So she enjoys teaching biology and sciences with the interactive lessons, personalized feedbacks, and helping them with guidance, expert guidance. So in a nutshell, Damilola is committed to helping you to achieve academic excellence and long life love for sciences. So that takes us to what we need to expect for this program. Now, what do we expect? So you learn key concepts of sciences, which are energy, matter. It does not matter whether you are in grade 1, as long as you can follow along and you can understand the basic things that we are talking about, because we are going to be using the language that you understand. You should be able to grasp the concept of matter and energy. And also, it's very interesting to talk about the Earth system. What is responsible for the weather, what is responsible for the climate, and whatever. All right, so what we just want you to do is to have your notebook and pen. What we want you to do is to have your notebook and pen ready. Just pay attention and have a positive attitude. And please leave your comments and your questions towards the end of the webinar. We will take your questions. We will take your questions. Please. Thank you. At this juncture, if you want to discuss with us about how you can benefit from our programs and how your children can benefit, please reach out to us. We will be reaching out to you at the end of this webinar from Monday. And today is Saturday. We're going to be reaching out to you. Please do well to reach out to us. So I'm going to be handing over to Damilola. So I'm going to be on sharing my screen. I'm going to be handing over to Teacher Damilola. So Teacher Damilola, please do well to share your screen and start. Thank you. And please do not forget to unmute yourself. Thank you. We can't hear you.
Hello?
Now we can hear you now.
All right. Good day, wherever Hello, everyone. You're welcome to this science webinar. So today, talking about, am I still audible?
Yes, you are still audible. Go ahead.
Going to be talking about go into energy resources. Let me ask you a question. How many of you have used electricity this morning, maybe to boil water, to charge your phone, or to turn on the lights? Electricity here, it came from energy source. So what is energy? Energy is simply ability to do work. The fact that you can or eat up something or you can carry something to do work. And we are going to be talking about what the we have different forms of energy. We have energy from the sun. We have energy from water that is known as hydro energy. We have energy from the wind, uh, geothermal energy. We have energy from waste products, that is biomass, born waste product. You can get energy from them. You have energy from the sun energy. Those are forms of energy. We use energy to, what are the things in our daily life that we use energy? We make use of energy for cooking, for light, maybe to light up a dark environment, for transport. The bus will enter to school, your bus, or the bike, or you just walking, you make use of energy, different forms of energy. Cook. Maybe you're making cooker, you're making use of that is you making use of energy about are gotten from different sources, natural sources mainly. The one from the so we have energy from the sun. No, sun is a natural resource. We have energy from water. Water is also a natural resources. We have energy from the wind. Those are sources where we can get our energy from. Then we are going energy resources. We have just finished talking about what energy is. So, what is this energy resources we are talking about? So, energy resources is a process that are used to produce how, for example, food resources that we are going to be looking at what are the process that this food has to carry for to be prepared. So energy resources has to do with things that can be used to produce energy, such as light, such as heat, such as electricity. And these generally categorized as we have two main types. Renewable, that means you can reuse them. And another one is non-renewable. That means it's finished. You can't get more of it again. So what is renewable resources? Renewable. That means used repeatedly. That means you can't get enough of it. You can use it repeatedly and you can't run out of it because it's naturally replaced or replenished in the earth. For example, the sun is sun, what we call the solar energy. The water found naturally. And the water hydroelectric energy. And these renewable resources are natural from they are that means they are found in our environment. You don't have to do any work to get this resources. They are sustainable and you can reuse them. That is the main thing. Why for non-renewable resources it is limited and it is millions of years to be replaced once you examples of renewable energy from the word renewable. We say renewable is something that is being used repeatedly and you can't run out of it. It's being used repeatedly and you cannot never run out of it. So we are going to be looking at examples of this renewable energy. Number one, they are clean and they are sustainable. Examples are solar from the sun. Then we have biomass, that means from burnt waste products. We have geothermal, these are energy from the the movement, the energy produced from the movement of. Then we have tidal energy from hydro energy, energy from water, a body of water. Then what are the advantages? We just said this is very clean, and advantages of this solar energy. Clean and sustainable. They reduce pollution. There is no way the sun is going to pollute the environment, because imagine you're getting your energy resources from the sun, which is solar energy. There is no way the sun is going to pollute the environment. Never run out of renewable energy. Remember, they are naturally abundant. The water is always, you can never run out of them. But once we have advantages, we also have some disadvantages. The advantages of this type of energy, that means depending on the weather condition in your environment, this particular source of energy will take effect. For example, environment that you have, maybe you are in the winter season, that means there is no little or no sun, or you're in the rainy season, not solar energy. Why? Because there will be little or no sun to power your solar. So it is weather dependent. Or if you're in a region where there is the season where there is little or no water, you cannot make use of power, because you need body water to get a dam to be able to power your house with hydroelectric water. So you see, it is weather dependent, depending on the weather. So it is weather dependent. Then it has high setup cost. That means you have to think about it to be able to set up it. Then you need large areas. You need large areas to be able to set up this type of environment. Then we are going to be looking at what renewable energy. Examples of non-renewable energy: coal, from charcoal. We have from crude oil. Then we have gas, we have crude oil, we have cider. So what we are going to be looking at advantages of this renewable energy, just like the way we looked at advantages of table. It can be used replenished, because it is found in nature. You can find them around you, like the sun, the water. Why is once you buy a pack of charcoal, use it is done. You can't, unless you can't reuse it. So examples of this non-renewable is coal, oil, natural gas, or new. And advantages is they have high energy outputs. They are cheap, easy to able energy. Disadvantages they have limited supply. They cause pollution. Imagine on your generator, and the stuff from the generator is going to a whole in the environment. Sound, noise pollution affect you yourself. Another form of pollution. This energy can cause different forms of pollution in the environment. You have noise pollution, pollution by you owning your generator, or by you burning a. So these are the disadvantages, and it causes damages to the land. In the process of you mining the land to get crude oil from the land, you damage, which is a disadvantage to farmers that are expecting high yield of farm produce. No renewable energy in Water Canada, we have oil sands, natural gas. The renewable ones are hydropower. These are all everywhere. Wherever you go to, renewable energy will always have to do with something that you can find around you, that are natural resources. We're going to be looking at what are these things that we have to look at before choosing, before making an energy choice. That means if you want to buy energy for your house, to power your house, you have to look at some things before you can, okay, oh, I'm fine with solar. Remember that the renewable energy is weather dependent. So if you're in an environment that have more rainfalls, that means you cannot really go for the solar energy, because the solar energy has to do with the sun. So you have to look at where you are, the availability and accessibility, where you're living, the weather condition, the climate of where you're living. You have to look at the economic factor. Do you have a space to be able to have this particular energy? Remember, I said the renewable energy, you need a large surface area. Why the non-renewable, you don't need a large surface area? Then you're going to be looking at the environmental impact. Remember, I said non-renewable energy can actually cause noise pollution. So you're going to be looking at the environment where you are. Oh, is my generator, or what I'm going to be using, going to this particular environment? So pollute this particular. Then we are moving on to, okay, from what we have learned so far, we've talked about energy and their resources, and there are different types of examples of this energy resource. Can you tell me what resource is solar? Is it renewable energy? Is it renewable energy? And where is it gotten from? What about for the hydro energy? Where is hydro energy from? And is it renewable or non-renewable? And what about the tidal energy? Where is it got not renewable? So I'm going to be calling out this energy. So you're going to, is it or not renewable? The solar, is it renewable or not renewable? The coal, is it not renewable? Is it renewable? The wind, the energy gotten from the wind, is it renewable or not renewable? The oil, is it renewable? I expect your answer. So moving forward, we are going to be looking at how can we be responsible for our energy management. Remember, some of this energy we have to be responsible in the management of our energy. That means you have to minimize the disruption of nature and wildlife. That means make sure the type of energy you're going for does not affect nature, does not affect the wildlife, like the animals. Is going to restore and rehabilitate the land after the resource extraction. Imagine you're extracting crude oil for an environment that makes use of extract crude oil, they mine crude oil to produce petrol, gas. So you have to make sure what hope is not going to proper handle and dispose of energy. So you properly manage and dispose of such energy. Then we are going to be looking at how do we use this energy in our daily lives? Number one, we make use of energy for heating and cooling. That means to keep our homes comfortable. We make use of it for air conditioning. If you have electric energy at home, use it for air conditioning, for heat pumps in the bathroom, for lighting, to light up a dark light bulb. If you make use of electric stove at home, you make it to cook. If you have gas, that is another form of energy. Make use of firewood, that is also energy in place. And you make use of energy to transportation, house to your car. Your dad drives you from the house to the place in the car. You use walk, then like human power, the ability for you to walk. To work, that is energy. So we are just come to the end of the class, so but I have a little challenge for you. So this is what you can see on my slide is showing solar energy that is energy from the sun. The coal energy gotten from fossil fuels from underground. Then with the wind energy gotten from the wind, we have hydro energy. So what you're going to do is you click on each energy source. Me, is renewable or not renewable? So let's start. Is solar energy renewable or not renewable? Is coal renewable or not renewable? Is the energy gotten from nuclear radiation not renewable? What about hydro? Is it renewable or not renewable? So let me get your answer in the comment section. Then tap processing. So you decide uses happen before or after. So you get the answer. Let me get the answer. Then, so I want you to become and convince the class and convince this class. You're going to tell us the particular energy you use at home. Then you're going to tell us why you think that is the best energy. Use it. The energy you're using at home is the best energy. So, okay. I've come to the end of the class.
Can you hear me?
Yes.
So is nuclear energy renewable?
It's not renewable.
So it's something similar to like fossil fuel, right?
Yes. Yeah.
Not renewable. But the thing is that some of these nuclear power plants can run for decades. So are they renewing the energy sources one by one, or those how would I call it, those nuclear energy sources, they just run for longer time than fossil?
Hello?
Did you hear my question? I said,
No, go ahead.
I said some of those energy sources, some of those countries that have nuclear energy, some of
Yes.
them, those nuclear plants run for decades, and some of the nuclear cells in the nuclear plants actually can run for decades. So is it that because maybe they run or they decay slower than carbon? Because for hydrocarbon, once you buy the fuel or you buy all those products of product of refinery, they burn very quickly, So can you make some comments about the nuclear energy? What makes it not renewable? And then so that we just run.
Okay, the nuclear energy is considered non-renewable because it relies on uranium resources. The renewable energy depends on natural resources. So the energy, one of the main reasons why nuclear energy or uranium is considered not renewable is because the uranium, the main component, which is uranium, is not naturally produced. It's natural replenish at a rate compared to their consumption. So power is a low carbon, high capacity, doesn't produce greenhouse gases if emission like fossil. So the main reason is because the uranium itself is not naturally found. Uranium is produced. Hello?
Hello, I understand you. Okay, thank you very much. Because of our time, we have to move on to the next thing. Thank you very much. I was lightning, and we were able to understand a little bit about energy. So we were able to understand a little bit about more about energy, whether they're renewable, not renewable, and why we need energy and all that. Thank you very much for the enlightening session. So we appreciate if you can share your screen, and I'm going to call on Madam Kemi. Kemi, please feel free to share your screen with us and tell us a little bit about. I believe you're going to talk about heart system, right? Am I pronouncing it correctly?
All right, good evening, everyone. So I don't know if you can see my screen.
Yes, we can
Yes.
see your screen, but now it's gone.
Okay.
You can share your screen again.
All right. Good evening, everyone. It's my pleasure to be here tonight. So today I'll be discussing the topic health system, and I will be following the Canada curriculum for grade 6. So my table of contents, I have the introduction to the health system, the earth interactions, human interaction, climate change. So the curriculum actually wants us to look at the components of the earth system and how climate affects the earth system. So I'll be looking at earth system and I'll be talking more on the climate change also. So I'll go straight to the definition of the earth system. The health system complex uh, is a complex system, and it consists of different components, majorly the land, air, water, and the living things. So scientifically, we have names for all of these components. The land is referred to as the geosphere, the water is referred to as the hydrosphere, and the living things are generally referred to as the biosphere. You need to know that living things consist of plants, animals, and the tiny little organisms we can't see with our naked eyes, which are called microorganisms. So now the Earth system science is the study of all of these components of the Earth that I've just mentioned. That is the geosphere, the hydrosphere, and the biosphere, and how they interact with each other. So that is the Earth system science. Moving on, I will look at the interaction within the Earth system. Earth system interacts with the sun. That's the first thing. Eh, I'm sure that my learner should have been taught or should have idea on a topic called solar system, whereby we know that we have different planets and how they relate with the sun. So we call the relation of the planet with the sun solar system. So Earth is the third planet, and its interaction with the sun is also referred to as the solar system. And what does that lead to? The rotation of the earth around the sun is what gives us day and night, and it takes 24 hours. And the revolution of the earth around the sun is what gives us our different seasons: the winter, the autumn, the spring, the summer. So, and that takes a year, 365 days. uh, so the first interaction with the head is the first interaction about air systems. What is the interaction with the head with the sun? And also the head interacts with the sun in various ways, like clouds reflecting sunlight into space, greenhouse gases trapping it from the sun, ice reflecting light from the sun. So moving on, human interaction with the health system. Like I said earlier, we have different components of the Earth system, and one of these components is the biosphere. And I listed that the biosphere consists of plants, animals, and living things. Animals consist of both lower animals, the common animals, and the higher animals, which the human being is categorized under. So definitely, human is let me say a sub component of the biosphere, and we interact with the health system a lot because we do a lot of activities that directly or indirectly affect the earth system. So humans rely on the sun and earth system for a habitable climate. So we depend on the sun and the air system. For instance, I said during the day, that's where we carry out our activities. And the earth, we get a lot of things from the different components of the earth. For instance, the hydrosphere, that's where we get our water, the and we also get some other living organisms in the hydrosphere, like plants and some other animals like crustaceans, crayfish, fish, and all of that. And then the geosphere, that's where we build our shelter, and we also plant some things that we eat. So definitely human interacts with other components of the earth system on a daily. So we also need the interaction of the earth system with the sun for geographical location factors such as latitude. I explained solar system the other time, and it's in a way work with latitude. How farther is the earth from the equator? It will determine the part of the earth that is experiencing the now. I don't know if my learner is in Canada. Right now, we are at night, and I know that it's another geographical time zone in Canada. So this is latitude is one of the things that determine it. How far is the earth from the sun? What part of the earth is tilting with the sun? So that will determine day and night. Proximity to a large body of water. This is what when we are close to that body of water, and that's why some regions experience cold weather. Some regions experience warmer temperature, elevation, urban and rural settings. Urban, I would say it's like industrialized environments. Rural settings, we don't really have much people. But in an urban settings, we have industries that give out different pollutants into the air, so that can affect, that's a component of the health that can be affected, and that's air pollution, different pollutants into the water bodies. How is human activities affecting this? So human are the ones, how are we affected? When there is air pollution, definitely there are different things that can be taken into our system that can lead to something like respiratory disorder or diseases. Or when our water bodies is polluted, we definitely will not have by living organisms that can be consumed. Or whether our land is polluted, where do we plant? Where do we get our food from? So changes in climate can be caused by natural processes, including volcanic eruption, that's flooding, which could lead to migration of some species from particular region to another, or even destroy properties, making human homeless, or even destroy our plants, making it difficult for us to get food. Meteors, these ones, the release a lot of the dust and all of that, that blocks the air system, which can lead to warming, global warming, changes in sun output, changes in orbit. All of these affect our affect the way we live, or how habitable is the earth for us in a way. So let's look at climate change and its effect on earth system. Like I said earlier, looking on the curriculum expect us to look at the effect of climate change on earth. So changes in climate can be caused by human activities like industrialization and pollution. I think I explained that when I was explaining urban and rural settings. Industries, they have a lot of effluents that they release into the water bodies on the land. Vehicles, there are machines that release different pollutants into the air, like carbon dioxide, for instance. We know that we have it naturally present in the atmosphere, but in a little quantity. When it is more than that quantity, then it becomes a greenhouse gas, which could definitely lead to warming, global warming, or warming, temporary warming. So reduce. So how do we face this challenge? By all of us human beings creating an atmosphere for clean energy production, like reducing thank God my colleague talked about energy, reducing our consumption of energy that can contaminate the environment, like reducing the use of crude oil, so which release pollutants into the air, like instead making use of some energy like solar panel, windmill, which does not really have effect on our environment. And by planting gardens, we all know that when we plant trees and we have gardens, we know that these ones make use of the carbon dioxide that will breathe out in manufacturing their food, and in return they give us oxygen, making our environment very clean and habitable, and making the earth a better place. So personal impact on climate due to interaction between the sun and the earth. So climate change can affect weather and weather and can lead to extreme weather events. Later on, we'll look at some of these extreme weather events that we can have. Migration pattern. I talked about flooding that it could lead to some of species leaving the environment. Even humans can run away from a particular habitat because of natural disasters such as flooding, or even wildfire or volcano, etc. So frequency of forest fires. These are the things that could lead to that could result from climate change. Whether the climate is too cold or the climate change has led to warmer temperature. So forest fire, for instance, when we have extreme temperature, so we could experience forest fire. Now, climate can impact agricultural activities such as irrigation. For instance, where there is extreme droughts due to high temperature, where do we get water to irrigate our plants, our vegetables and trees and things that we have planted in our gardens? Crop production, definitely when a plant is not getting adequate nutrients, which a key nutrient is water, there will be low yielding crop protection, and that could lead to famine, so making the earth not so habitable for us to live. Now, I talked about extreme weather event as one of the outcome of climate change. So we look at some of these extreme weather events that occur on Earth. This include heat waves. That's when we have extreme temperature, high temperature, and it could lead to wildfire, it could lead to forest fire, hurricanes, and so on and so forth. Now, extreme weather events that occur in Canada include tornadoes, blizzards, torrential rain, wildfire. This is particular to Canada. So, and they've experienced it in different part of Canada. So, I, I am going to put it to my students that just to know if you have really gotten something from this class. So just two questions, and the first is relate weather events to specific location in Canada. For instance, if you look at the extreme weather event that I've listed, tornadoes, can you really tell me a particular place in Canada that has experienced this? So that's what I am trying to ask. Weather condition, weather events to specific locations in Canada and on Earth. But I wanted to narrow it down to Canada because I am following their curriculum right now. And then discuss possible effects of climate change on land, plants, and human. How does climate change affect land? How does climate change affect plants? And how does climate change affect human? All of these things that I've listed are components of the Earth system. So I'm simply asking you, how does climate change affect the components of the Earth system? So I need a response. Are you there? I'm waiting for a response.
Yeah, we don't really have a lot of students online, but I mean, we are recording the session, so you can replay it for them.
Okay.
Thanks. Well, thank you very much for your presentation. We are still
All right.
doing very well when it comes to time. So, Mr. Abayomi, are you ready? Thank you, Mr. Abayomi, are you there? Hello? Abayomi,
Using, okay.
can someone help me call his name?
Using the call, yeah, and he has muted himself.
Abayomi, you need to start your presentation, please. If you are talking, we can't hear you.
Well, Bayomi, please share your screen. We'll wait a couple of minutes. If you cannot share your screen, then we have to end the meeting.
Can you hear me now, sir?
Yeah, we can hear you, but you need to share your screen.
Okay. So welcome to today's class. I'll be taking you on the topic state of matter. So let me quickly share my screen. Can you see my screen now?
It is coming up. Now we
Okay.
can see.
Okay, can you see my screen now? So
Yes.
today I'll be taking you on an interesting topic. Now, which is the state of matter. So we are going to look at the various states in which matter exists. So we have three states of matter, which is the solid, the liquid, and the gas. Now you can see a picture. Inside this container, we have a solid being deep in a liquid. So if you can see that this is a picture of an ice, so the state of that matter is solid. Then you can see that in this container, we should have something likely to be water, and the state of the matter is a liquid. So we are looking at the topic, the state of matter. Now, but before we continue, let's look at what is matter itself. What is matter? Do you know that everything around us is matter? Everything you can see around you, from toys to water, and even the air that you breathe. Your table is a matter. You are a matter. This jug that you can see in this picture is a matter. This cup is a matter. The ice cube you can see here is a matter. Then let's look at the definition of matter. Matter is anything that has mass and that take up space. Consider anything in the universe that has a mass and that can occupy space. That thing is a matter. The food you eat is a matter. The air you breathe is a matter. Now, that leads us to a question. What does a matter contain? Now, do you know that the matter we are discussing is made up of a particle? So a particle is made up of a tiny indivisible parts. And that tiny indivisible parts, when they come together, they form a matter. Now look at this picture, for example. If you look at, this is the state of matter. We have gas, we have liquid, we have solid. Now in a gas, we have these particles in a gas. In a liquid, you also have a particle in a liquid. In a solid, you also have a particle in a solid. So what made up matters are called particles. And particles can be defined as indivisible tiny particles, indivisible parts. And when they come together, they make up a what? A matter. So for our today's class, we are looking at the states of matter. Matter can exist in 3 states. We have the gas, the liquid, and the solid. When you have the gas, the liquid, and the solid, inside them is what we know as the what? The particles. Now, let's continue with our class. We want to look at the description of solid particles. Now, in a solid, like you can see in this picture, if you look at this picture, this is the picture of a solid. Inside this ice cube, you have these particles. So let's look at the properties of these particles. Now, number 1, in a solid, the particles are packed tightly together. You can see it here. If you look at it, they are packed. This is one pack. This is another pack. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in a solid, the particles are packed tightly together. Not only that, these particles that are tightly packed together, they vibrate in a fixed position. You can see they only vibrate in a fixed position on a spot. Their particles don't have the freedom to move around. Why? Because they are closely packed together. So they only vibrate in a fixed position. Let's move further. Have you ever think of a classroom sitting in their seats? Now let's assume we have a classroom of 20 students. You can see that in a classroom is arranged in a way whereby they are closely packed together. In a classroom, we don't have chairs scatters all around. We arrange them accordingly. So that is how the particles of a solid are. They are tightly packed together and they vibrate in a fixed position. Let's look at the properties of a solid. Now, one of the properties of a solid is that a solid will have a definite shape and also a definite volume. Now, let's consider this ice cube, which is a solid. If you look at this ice, when you look at it, you can tell us that, oh, this shape is the shape of a cube. So a solid will usually have a definite shape and also what? A definite volume. And this is the properties of a solid. Now, let's look at a fun fact. Do you know that some solid can change shape, like your clay? Now, your clay is a solid. It can change shape when you squish it and mold it into different form. You know that we do mold clay into different form. Now, let's look at examples of a solid. We have your ice, we have a table, and we also have a rock. These are examples of solid matter. Now, let's proceed. Let's look at understanding the description of liquid. In a liquid, let's go back to that picture. The particles in a liquid, look at the particles in a liquid. They are not closely packed like that of the solid. So in a liquid, what can we say about their particles? Their particles are close together, but they are not tightly packed. They are closer to each other, but they are not tightly packed. But they can slide past each other. If you look at it, you can see them there. They are close to each other. Look at, they form pairs. They form pairs, pairs of 2, pairs of 4, pairs of 3. So they are close to each other, but they are not tightly packed. So that is the particles in a liquid. Think of a student. For example, let us think of a student walking around the class. Now, you know, in a classroom setting is an organized setting. Then we now have a particular student just roaming around the class. That means that student can walk past each and every one of us in the class. So that means in a liquid, if you look at the particles are close to each other, but still yet they can still move around. They can still move around. And that's where the word slide over each other comes in. They can move around. They can move around. I don't know if you have any question between the particles in a liquid or a solid. If you don't have any question, let me ask you one question. Can you differentiate the difference between the particles of a solid and the particles of a liquid? Can you differentiate it? Any idea, please? Anybody in the classroom? Can you tell me one difference between the particles of a liquid and that of a solid? Okay, in the case of no idea, the particles of a solid, they are closely packed together, while that of a liquid, they are closely together, but they are not tightly packed, so they can slide over each other. Examples of a liquid is water, juice, and milk. Then let's look at the properties of a liquid. For a liquid, one of the properties of a liquid is that a liquid has a definite volume. The volume can be 1 centimeter, it can be 2 centimeter, it can be 10 centimeter cube, it can be 100 milliliter or 10 liters. Now, in a liquid, they have a definite volume, but they take the shape of their container. Have you seen a bucket of water before? When you look through it, you will see that the water actually takes the shape of the bucket. When you put a water in a bowl, when you look through it, you will see that the water will take the shape of the bowl. Also, when you put a water in a cup, you will find out that the water will take the shape of the cup. Now, you can see this picture here. This is an example here. If you look at this picture, this is a glass cup. And in that glass cup, we have an orange juice there. You can see that the orange juice actually take the shape of the glass cup, like you can see in this picture here. And that is the properties of a liquid. Now, let's move to that of a gas. Understanding the description of gas. In a gas, the particles are far apart. You can see it in the pictures here. Look at the particles. They are far from each other. So we use the word, the particles are far apart. They are not close, like in the case of the liquid and that of the solid. And that's what differentiates the particles in a gas from that of a liquid and a solid. They are usually far apart from each other. Let's see. what we need to know about the particles of a gas also. Now, these particles that are far from each other, they also move around quickly and they move randomly. If you look at it here, look at the particles of a gas. They are far apart from each other. So it is very easy for them to move around. And when they move around, their movement does not have a regular pattern. Their movement is scattered. And that is why we said their movement is randomly. Now, for example, let's think of a student running around the school. Let's assume in your classroom, there's a boy called Herbert. And Herbert has been running around the school yard. And your teacher asks you, please call me Herbert. It is very difficult for you to locate Herbert because he has been running around the school yard. So his movement cannot be determined. His movement is random. Because you don't know, maybe Herbert is in grade 5 class, or is in grade 6 class, or is in grade 1 class. So Herbert's movement cannot be determined. So that is why in that of the particles of a gas, the movement of their particles is random. So if you look at it in this picture, you can see that their movement is random. You cannot determine their movements because they are what? Far apart from each other. So let's see properties of a gas. Gases do not have a definite shape or volume. They don't have a shape. They don't have any volume. They only fill the space they are in. Gases are only contained in a steel container. So they don't have any shape, any volume. An example of a gas is the air that you breathe. Every day, we breathe in air. So it's an example of a gas. What of steam? When you have a boiling rice, we have some vapor, like you can see here. Let's see, for example. Look at, this is a jug. And you can see some vapor coming out from the mouth of the jug. And this is what we call steam. And the state of matter for steam is a gas. So example of gases are air, steam, then helium. Helium is an element that is used in filling balloons. Helium is an element that is used in filling what? In filling balloons. Now, have you ever seen a parachute before? A parachute is also a form of a balloon. And what we use to fill a parachute is helium elements. Now, let's continue with the slide. Now, let's look at changing the state of matter. Do you know that matter can be changed from one form to another? You can change a solid matter to a liquid. Then also, you can also change a liquid matter to a gas. A gas matter can also be changed to a solid. So we have changing of state of matter. Now let's take, for example, an ice cube. This is an ice cube that you can see here. When you supply it to an ice cube, what will happen? It will change to water as a result of supplying it to it. That means an ice which has a state of matter which is solid has been changed to water And the state of matter for water is liquid. I don't know if you have any question on that. So when you place an ice cube in a clear cup, when you get home, you can try it. Get an ice cube, place it in a clear cup, allow it to melt. You will see that that ice cube have changed to a liquid form. It has changed to water. And the state of matter for that water is liquid. Why the state of matter for that ice cube is solid? That means matter has been changed from one form to another. Let's continue. Look at it in this picture. This is an ice cube. When it changed to water, that process whereby an ice cube changed to water is called melting. This ice cube, the state of matter is solid. Then it changed to water. That means it has changed to a liquid. The process whereby the ice cube changed to that liquid is called melting. Now let's consider the process whereby water changes back to that ice cube. Don't forget, if you put your water in a container and you keep it in your refrigerator, after some times that water in that container will freeze. And when it freezes, it turns to a solid, an ice. So from there, you already know that your water has been changed to an ice. That's water, which is in form of liquid, have changed to a what? To a solid. Now the process whereby a liquid change to a solid, that process is called freezing. Let's consider water changing to a gas. When water change to a gas, let's take for example, you have your liquid water. When you boil it, then it now change to steam. That process whereby it change to a steam is called evaporating. It's called evaporating. At that point, a change of state of matter has occurred. That is, the water, which is in liquid form, have changed to a gas, because your steam is an example of a gas. Now also, do you know that your steam can change back to your liquid water through a process called condensing? Or you use the word, the process is called condensation or condensing. This is your steam. Look at the picture here. Changing back to liquid states in form of water. And that process is called condensing. Now, that is how matter change from one form to another. An ice can change to a water. That process is called melting. While the water can change back to an ice, that process is called freezing. And that is the way matter changes from one form to another. I know you are in Canada. You do have snow. Now, if you look at your snow, it's in form of an ice. When you add salt to your snow, after some time, that snow will melt to form water. That process is called melting. Now, when you keep your water in your refrigerator, it changes back to an ice. That process is called freezing. And that is how matter changes from one form to another. Now let's look at the last slide. Let's look at the physical properties of a matter. One of the physical properties of a matter is that, number one, matter has a state. It can either be what? A solid, a liquid, or a gas. These are the states which matter occur. It is either a solid, liquid, or a gas. Then also, all matter has a mass. That is why from the onset in our class, we define matter as anything that has mass and that can occupy space. Then also, matter has a volume. Volume is the amount of space a solid, a liquid, or a gas takes up. So the amount of space that a solid, a liquid, or a gas takes up, that is what we call volume. And this volume we are talking about, it has a unit of measurement. The unit of measurement for volume is either milliliters or liters. That's the unit of measurement for volume. It is either milliliters or liters. Now, if you check your bottled water, you will always see that they have volume. Some might be 20 liters, some might be 10 liter, some might be 5 liter, depending. So matter has a volume, and this volume we are talking about, it has a unit of measurement, and the unit of measurement is milliliters and liters. Now, for that of a mass is the amount of matter in a solid, liquid, or a gas. A mass is the amount of matter in a solid, liquid, or a gas. This mass too also have unit of measurement. Mass is usually measured in grams or kilogram. Like, for example, if you go to the market, they will weigh. Let's take, for example, you want to buy chicken. The chicken will be weighed on a weighing scale.
Mr. Abayomi, we have
Sir.
5 minutes more.
Sir?
We have 5 minutes more to round up.
Okay. So the chicken will be weighed. So it is either weighed in kilogram or what? Or grams. So I don't know if you have any questions so far on the topic state of matter. Any question? Any question on the topic state of matter? In conclusion, matter is anything that has mass and occupies space. That is the definition of matter. Matter is everything that can be found in the universe. Example of matter can be a desk, the air you breathe, the food you eat, your pencil, your biro. You are a matter. Your teacher is a matter. Your parents, they are matter. Lastly, don't forget that matter has states, and the state of matters are solid, liquid, and gas. Lastly, do you know that what makes up a matter is called a particle? And a particle are tiny, indivisible parts. Thank you very much for attending today's class. I would like to meet you in the next class. Assignment before you go. Can you define what a matter is? That's number one. Number two, can you find out what a density is. Thank you very much. I hope you enjoyed today's class. See you some other time.
Thank you, everyone. Thank you, everyone, for coming. Thank you for the presenters, to the teachers. So I hope we understood concept of energy. Today we delve into energy, the earth itself, the matter, which also the makeup of the earth. So yeah, so the webinar, the recording is going to be on our YouTube channel. And we will, if you want to watch, we can send you the link, or you can search for our YouTube channel, Educify, EDUCIFY Inc. on YouTube. You can, and we'll try to also make sure that maybe we will upload it on Facebook as well, but mostly on YouTube. And we'll be reaching out to you shortly to discuss with you how we can introduce and work together in the exciting world of sciences. We want to thank the speakers, Madam Adeniyi Oluwakemi and Oluwadamilola Fasholu. Thank you for your good presentations. Mr. Abayomi, thank you for the presentation. And so we draw the curtain on today's webinar. Thank you everyone for coming, and we are calling it a day. Thank you.